Hello everyone. In this video, we are going to do a sample question paper for mathematics standard, and that's issued by CBSE for the exam year, that is 2025-26, and this is what the code number. So let's begin with the first question. So what we can see in the first question, it says that if A is this, B is this, C is this, and the LCM of ABC is given as how much? 3780, then we have to get the value of X. So look for 2 here. Let's say 2 with the power 2, 2 with the power 2, and 2 with the power 2. So we can see that the 2 with the highest power is 2 only. So this is 2 raised to the power 2. And we look for the other one. Let's say if I see this one, this is 3 raised to the power x, 3 raised to the power 1, 3 raised to the power 1. So we can say that considering x to be a bigger than 1, so we can say that 3 raised to the power x is the highest factor. And for other numbers, this is 5 1 times and this being 7. So LCM for these numbers, that is ABC, should come as this, and which is given as 3780. So we can equate this with 3780. Now multiplying these numbers, this is 4 and this is how much? 35. So 4 into 35 is how much? 140. That multiplied by 3 raised to the power x equals 3780. Now we can transpose this 140 to the other side on dividing with 140. So it's 0 and 0 get cancelled. I can see it is further divisible by 7. 7 2 times 7 5 times is 35 and 7 4 times is 28. So we can reduce it further with 2 as this is coming as 2 raised 27. So now we can equate their bases. What I mean to say that we have now 3 raised to the power x equals 3 raised 27 can be written as 3 raised to the power 3. So we can equate their powers. So from here we get x as how much? 3. Equating their powers, right? Not their bases. We have the same base. So x therefore is equal to 3. So yes, so the correct answer will be the option C in this case. Now coming to the second question over here. So in the second question, it says the shortest distance in units for this point from the y-axis. Now always follow these steps that whenever it comes to a question of coordinate geometry, always try making a rough sketch, right? So question here is, it says the shortest distance in units of this point 2, 3 from the y-axis. So we can take a rough point somewhere that is 2, 3, x2 and y3 somewhere will be here, right? Just to make a rough sketch, this is 1, 2, and this is say 1, 2, 3. So this is the point which is 2, 3. And what they are asking, the shortest distance, they're asking for the shortest distance of this point from the y-axis. Well, they're talking about this distance. So clearly this is equal to how much? 2 units. You can see this is equal to 2 units. But anyway, one should learn it also and remember it. The distance of a point from y-axis is its x coordinate. I repeat, distance of any point from y-axis is its x coordinate, and distance of any point from x-axis is its y coordinate. So we are looking for from y-axis. So clearly the y distance from y-axis will be equal to its x coordinate, and that is 2. And the question number 3 says if the lines given by this equation and the other is this are parallel, are not parallel, right? It is not parallel. Then k is what? We have to get the value of k. So for not parallel, it can be what? Intersecting. So it can be intersecting lines like this. It has to be intersecting, right? Non-parallel by default has to be intersecting. So for an intersecting line, clearly it's a unique solution. And what we know for a unique solution, it is A1 over A2 is not equal to B1 over B2. So look into this. This is already in the standard form. So I can see from here the A is what? A is A1 is 3. This is A2 is not equal to B1. Make sure you take the whole thing, right? This is the coefficient of y. Coefficient of y is positive 2. So this is 2k, that divided by coefficient, that is B2 is 5 in this case. Now, if I do cross multiplication, this is what we get. We get as 4 times 2 into 2 is 4. 4 times k is not equal to 15. That implies k is not equal to 15 over 4. This is not equal to, right? So now look into the option. The question here is that then k has to be any real numbers except for 15 over 2. This question says ABCD is a quadrilateral that is drawn to circumscribe a circle. So as I said, always make a rough sketch. So I first made a circle and then I should make a quadrilateral so that it is circumscribing the circle, scribing it. So that means the quadrilateral must be touching, the sides must be what? Has to be the tangent. So let's say the quadrilateral has to be named ABCD as per the question. Further, it says that if BC equals the length of BC is 7 centimeter, CD, CD is 4 centimeter, AD is 3 again, and we have to get the length of AB. So we know that quadrilateral circumscribing a circle, then the sum of the opposite sides like AB plus CD is equal to AD plus BC. So if I apply this property over here, that means the length of AB and opposite of AB is CD, right? Plus AD plus BC. Now we have to get the length of AB, so we can keep AB as it is. We know the length of CD as how much? 4. The length of AD, this is AD as 3 centimeter and BC is 7 centimeter. So now we can get the length of AB. This is how much? 10, and 10 minus 4, that is 6. So you should write 6 centimeter. Anyway, this is an MCQ. So the correct answer is option C. Now moving to the next question, that is question number 5. Now, what does the question says? It says that if secant theta plus tan theta is equal to x, then we have to get the value of secant theta minus tan theta. If I write the identity of secant square theta minus tan square theta, which is equal to 1. And I can split this in the form of a plus b into a minus b. So this is secant theta plus tan theta. Applying the algebraic identity, right? This is a trigonometric relation or identity, and I'm splitting this in the form of algebraic identity of a plus b into a minus b, which is equal to 1. Now I can substitute secant plus tan as x, right? I'm placing x over here, that multiplied by secant theta minus tan theta equals 1. So on transposing 1 to the other side, x to the other side, we get secant minus tan as 1 over x. So we'll say that D is the correct answer of this question. It says which of the following is not a quadratic equation? Well, what is a quadratic equation? Any equation in the form of ax square plus bx plus c, right, equal to 0, where you should know that a should not be 0. That means the coefficient of x square should not be 0, and the highest power of this polynomial has to be 2. That means the degree has to be 2. Now we have to check for one by one. Let's say if I expand this, the first one, if I expand this, applying the identity of a plus b whole square, this is a square plus 2 times ab is 4x plus b square, that is square of 2, which is 4, equals 2 times x is 2x and 2 times 3 is 6. Now, yes, this is a quadratic equation. If I bring this 2x to the left hand side, 4x minus 2x is how much? 2x, and this is minus 2 equal to 0. So this is a quadratic equation. The first one is a quadratic equation, but they are asking for not a quadratic equation. So then I'm going to solve the other one. Let's say if I do this one, that is the second part, B part I mean to say. So here if I do the expansion, this is x square plus 3x is as it is. On the right hand side, this is minus. So let's keep -1 as it is. And then with the expansion of this comes out to be a square plus b square. The square of this is how much? Positive 9x square minus 2ab. So this is minus 6x. That's right. Now, if I open this bracket, this is x square plus 3x square. On opening this bracket, this minus sign will influence the inside number. So this is -1 minus 9x square and positive 6x. Okay, keeping this in the standard form, transposing 9 to the left hand side, it should give you 10x square. Transposing 6 to the left hand side, we'll get negative 3x, and transposing -1. Yes, it is a quadratic equation. Now checking for the last, no, C part, right? On the C part, what is it? This is what the question here. So let me erase a portion of this. As of now, we got first two as the quadratic equation, and I'm doing the C part now. So we have x cube minus x square plus 2 times x plus 1. And I'm doing the expansion of a plus b whole cube. This is a cube plus b cube is 1 plus 3a square b plus 3a b square. Well, 1 square is 1. Yes, so here you can see that x cube and x cube get cancelled. And we can clearly see that here square term does not get cancelled. So I can write this and this together as on the left hand side negative 4x square. This and this together as negative x plus 1 and 1 get cancelled. Okay, equal to 0. Still, it is a quadratic equation. Here, in this question, C is not 0, right? So in this question, what you can observe that this is still a quadratic equation. Here, C is 0, right? The condition is A should not be 0. So as of now, one can find out that the correct answer has to be the D part, but then I'm going to verify why D is the correct answer. So look into this. If I expand this, this is x multiplied by x is x square. X multiplied by 1 is x, and 2 multiplied by x is 2x. So I can write 3x, and 2 multiplied by 1 is 2 is equal to, this is x square plus 2x plus 3. So you can see that here x square get cancelled. And finally, we get this as negative from these two as negative x. And this is -1 equal to 0. As you can see that here, the x a is not there, right? The coefficient of x square is not there. So here a is equal to 0. This means this is not a quadratic equation. Well, we had to choose one which is not a quadratic equation. So clearly, D is the correct option in this case. In the seventh question, it says, given below is a picture of Olympic rings made by taking 5 congruent circles. Congruent circles are those circles with a equal radius or same radii. So we got one information on the radius is given as 1 centimeter each and intersecting in such a way that the chord formed by joining the point of intersection of circles also of length 1 centimeter, saying this chord, right? These are given as how much? 1 centimeter each. Now, if I read the next part, further it says, the total area of all the dotted region is what we have to find out. Let me magnify this part to understand properly. If I draw a chord over here, what you can see that this is actually 2 segment. How do I get? Look into this. If I shed this one, this is nothing but the area of a segment. So this you can see that it is representing the segment. And similarly, we have another segment on this side. This is segment. Similarly, you can observe that there are 2 segments, one on this side and the other as on this side. So we can see that altogether we have how many segments? That is 1, 2, 3, 4, 5, 6, 7, and 8. So in a way, we have to get the area of 8 segments. Moreover, what you can observe that here radii is 1 unit, right? This is of 1 unit as far as it is given in the question that radius of each circle is 1. So this is 1, this is 1, this is 1. So clearly, this is an equilateral triangle, right? We have this as equilateral triangle. So we can see that the central angle this has to be how much? 60 degree. So you need to keep these two things in mind, that we have an equilateral triangle here and we need to get the area of how many such segment? 8 such segment. So the required area has to be 8 multiplied by, and how to get the area of segment? That is sector minus the area of triangle. So sector area is what? Theta upon 360, and y theta, as I told you, is an equilateral, into pi r square, pi, and r is 1 square, minus area of the triangle. And we have already concluded this is an equilateral triangle, so it should be √3/4 times a square. Well, a is what? A is its side, and which is coinciding with the radius, right? So radius and side are same here, so it is 1 square. So this is 8 times, and if I reduce this, this is 1/6. So finally we have pi over 6 minus √3/4. 1 square is 1, right? And 1 being the multiplicative identity. Now, if I look into the question, options, we don't need to open the bracket. As I can see, we have an option like this. That is, D is the correct option in this case.